me the okay. Perfect. Thank you. Okay, so a little bit introduction of who Back to the Sea is, because I think a few of you that signed up tonight might have not actually known much about Back to the Sea before you joined. So our mission is to spark curiosity for marine life and inspire desire to protect our ocean. So the idea is that by bringing ocean life right up to people, really bringing it to eye level, people get to discover what's hidden beneath that big blue blanket. And then they get curious about it. And once they get curious, they start really caring about the critters and plant life that lives in the ocean, and then they'll want to protect it. So how do we do this mission? We operate the Touch Tank Hut, which has been open since 2017. It's a miniature marine interpretive center that is located on the Dartmouth waterfront near Albany Landing for people who are close to here. And it's mini, but it's mighty. It's got 2 large touch tanks, and since 2017, we've actually welcomed over 10,000 visitors. We did close last year. I don't need to explain why, but we're reopening this year, which is really exciting. So as long as public health recommendations allow, our goal is to be open in time for Canada Day. Yay! Last year, we did have a COVID pivot. Because the Touch Tank Hut was closed, we had tidal trekkers. So these are coastal guided treks that invite people to take time to be outside and get to discover coastal areas in Nova Scotia. Maybe places you've been to before, maybe places that you've never been to, but you get to see them in a whole new way with our interpreters and really discover what's lying beneath the water that you might not have always thought about, or you might not even know that certain things are animals. So by popular demand last year, everybody really loved them, and they said they wanted us to keep doing this even after COVID is over. So we are going to keep doing it. So stay tuned for our first Tidal Trekkers date as soon as we can safely do that. Our ultimate goal is to open a community aquarium along the Dartmouth waterfront. So here's a rendering of what we're working towards. The goal is to open our doors in 2025. And so while we're running the Touch Tank Hut and Tidal Trekkers and online educational videos, behind the scenes, we're always working towards this. And we're really excited to say that we've actually been doing ocean education for 5 years. This is what we're celebrating tonight, is our 5-year anniversary. This is a really huge milestone for any organization, and we're extra proud because we are a very small charity, and we did manage to navigate through COVID. So lots of great things to celebrate from the past and lots of great things to celebrate coming forward. And this event, we wanted to offer it to our supporters as a way to learn something fun as we celebrate our 5 years, but it's part of a larger campaign, which is called Making Waves. So we wanted to think of a way that we could impactfully celebrate these 5 years while also raising funds to allow us to keep doing our programming. And so Making Waves, we invite people to make waves on a monthly basis. The goal is during this 5th month of May, to recruit 55 new monthly donors, and if we are successful, we will receive $5,555 from Deloitte. This is a really big deal for us. It's one of the largest fundraisers we've ever done, and it ensures that people who do donate and become monthly donors, your support goes that much further because you're allowing us to unlock these funds from Deloitte. So we're really grateful for Deloitte's support, and we do have Sam Dyson here tonight from Deloitte who will say a few words. You there, Sam? Okay, let me just make sure he's there and not just struggling with his meeting. Sam. Oh, he's having audio issues in the chat. Okay. If want to continue, and you can say a few words at the end. Sure thing, Sam. Okay. All right. So yes, a huge thank you to Deloitte. And tonight, actually, we want to kind of throw out a little challenge. What I didn't mention is that people can become monthly donors at any amount. So you could donate $5 a month, even $2 a month, all the way up to $50 a month. That's the range we have right now, $250 to $50 a month and everything in between. So our challenge is we'd love to be able to recruit 10 more people. That would bring us over the 80% mark of having succeeded in the campaign. And then we know it's smooth sailing for the weekend so we can hit our goal by next week. But you don't have to decide now. Let's see how much you love our presenters. One little note, if you have questions about our presenters, please do put them in the chat. I'll be monitoring those questions. And at the end, I'll take the time to ask each presenter one question. And that leads us to our first presenter, which is Kaitlin. And I will let her share her screen and we'll get the fun started.
Okay, so can everyone see my screen? Perfect. I'll take that as an affirmative. So you might not have known this when you joined tonight's call, when you RSVP'd, when you woke up this morning, but I am pleased to tell you that you are about to fall in love tonight. The lucky match. How do I switch? Sorry, you guys are, the suspense is building. The lucky match, Algae. Okay, so you might not be in love with Algae quite yet, but in 5 minutes time, I assure you, you will be. So hello, my name is Kaitlin Burek. My pronouns are she and her, and I will be facilitating this love story. So everyone here knows that true love is found online, which makes it perfect that we're all here in this virtual environment. Like any good online profile, you will fall in love or deeper in love with Algae by, first and foremost, being wowed by its appearance and all the variety associated with it. Then starting to dig a little deeper, learning a little bit about what it does. Naturally, we need to know what it's looking for, so we'll discuss that. And then finally, where to meet, find, and revisit Algae. So, first impressions first, I want to introduce you to some beautiful brown algae. These are macroalgae found along Nova Scotia's coastline. So you'll notice the frills and elongation of Saccharina latissima on the left image and Alaria esculenta right beside it. At first glance, you might think twins, but you'll notice that Alaria has that midrib. Then hopping over to the third picture, you'll meet and admire Laminaria digitata. It always looks eager for a high five. And last but not least, it might be small, but mighty Agarum clathratum. So these are some of the browns, commonly known as kelps. Okay, now the reds. Corallina officinalis is articulated, coral-like, and fabulous from all angles. You can see that on the picture on the left. Palmaria palmata, which is the next in line, is not only stunning, but it's a great, great snack. In Nova Scotia, we eat it all the time. It's your dulse. Next up, another tasty algae, Porphyra, which can be used as nori, is nori. And okay, the last one, the one on the right, it might not be beautiful on the outside, but you have to admire Nemalion's confidence and its ability to wow every young person that lays its eyes on it. So we talked a little bit about the browns, the reds. Now check out the greens. There's 2 Ulva species on the 2 left sides of your screen. So we have Ulva lactuca there, and then we also have Ulva intestinalis right beside it. You might lock eyes with Ulva on your docks or on your boats. Now the buddy on the right, Codium. It is beautiful, but you can't like it too much. It's a toxic love affair because Codium frigile, the species we have around Nova Scotia, is actually an invasive species. So now that your heart might be fluttering a little bit, let's chat a little bit about what algae likes to do, going a little deeper. So everything, all the algae that we've seen so far is macroalgae, and that along with microalgae, which exists all in our oceans but is too small for the human eye to see, contributes to oxygen production. In fact, it contributes 70% of the oxygen that we use worldwide. So a lot to thank and admire it for. Not only is it a provider, algae is also a supporter. So invertebrates, fish, marine mammals, birds, all of these animals rely on algae at some point of their day or at some point of their life history. We also need to thank kelp beds, namely the browns, the ones that we drooled over earlier, for reducing waves and protecting our coast from coastal erosion. So they reduce the wave severity. Algae is looking for someone that is eager to help support the reduction of some of the anthropogenic stressors that it is facing that prevents it from being healthy and distributed and being abundant. So one of these stressors is invasive species. The image on the left is one perpetrator that brings invasive species to our coast. This picture is a ship that's unloading its ballast water. And in that ballast water, sometimes there's little hitchhikers that come from other waters that when introduced in our waters in Nova Scotia, take over. One of these invasives is called membranipra, which is a feisty bryozoan that makes kelp, or those big brown algae we admired earlier, brittle. And another huge problem, I'm sure you're going to hear about it a lot tonight, is climate change, specifically ocean acidification and warming oceans. Not good for algae, not a fan. Okay, so now that everyone is pretty pumped about the thought of spending more time with algae, I am excited to say that you can find it everywhere. Whether it's microalgae in the water column, you might not see it, but you know it's there, or macroalgae along rocky coasts, algae is all around. And it is very, very, very eager to meet you. And that's my presentation. A lot of heart eyes I see. Thank you, thank you.
Thank you, Kaitlin. You all can, everybody in attendance, if you want to use the reactions on the bottom of the bottom bar of Zoom, you totally can. Okay, next up we're gonna have Ruby.
Okay. Give me 1 second
Oh,
here.
right, you're sharing it yourself. I forgot you were sharing.
Oh.
I almost took over for you.
Oh. Okay, let me see if I can figure out how to do this here. Okay, can you guys all see my screen?
Yes.
All right. So first of all, thank you for having me for this wonderful event to celebrate 5 years of the Back to the Sea Society. I am very honored to be joining you from the unceded territory of the Squamish, Musqueam, and Tsleil-Waututh nations here on the west coast of BC. So, oops. My name is Ruby. I worked for 14 years as an aquarium biologist with the Vancouver Aquarium. I helped open the Petty Harbour Mini Aquarium in Newfoundland as the founding curator and general manager way back in 2013, and that's where I had the pleasure of meeting Magali in 2014. So for now, if you can't hear my sound of the ocean here, I'd like to invite you all to just watch the ocean and just see how that's making you feel. I hope you all experienced a sense of calm wash over you as this video played, maybe even the slowing of your heart rate and the release of a steady stream of feel-good chemicals into your body like endorphins, which create the peaceful euphoric feeling, oxytocin producing the trusting, calm, warm mood, and even the pleasure rush of dopamine. When humans think of water, see water, get in water, even taste and smell it, they feel something. These instinctual and emotional responses occur separately from rational and cognitive responses. They arise from the oldest parts of our brain, and in fact can occur before any cognitive responses arise. So to understand our relationship with the environment and to encourage the protection and preservation and restoration of our natural world, we must tap into both our cognitive and our emotional interactions with it. This is where the important work of conservation, education organizations such as the Back to the Sea Society resides, fostering both love and curiosity for the sea. However, it's difficult to convince people to care about the environment or ocean conservation if they themselves don't feel okay. Among other things, this past year and a few months of pandemic life has been a pressure cooker of struggle and stress for many of us. The good news is, if we create a relationship with water, not only can we heal ourselves both physically and mentally, but we can also cultivate a conservation mindset at the same time. I'm here to share with you the magic of the book I read a few years ago by Wallace J. Nichols called Blue Mind, the surprising science that shows how being near, in, on, or underwater can make you happier, healthier, and more connected, and better at what you do. The Blue Mind story seeks to reconnect people to nature in ways that make them feel good and shows them how water can help them to become better versions of themselves. I'm going to read to you the synopsis or the back cover blurb because it's compelling and I couldn't say it in any better of a way. Water attracts and fascinates us, and we know instinctively that being near it reduces stress, increases creativity, and brings us peace. Now, Wallace J. Nichols reveals a wave of research that's illuminating water's powerful effects on our bodies, minds, and souls. Drawing upon breakthrough science and compelling personal stories from top athletes, leading scientists, military veterans, and gifted artists, Nichols shows how proximity to water improves performance, diminishes anxiety, amplifies creativity, expands compassion, increases professional success, and improves our overall well-being. Blue Mind reveals how to harness water's tremendous benefits from sea to swimming pool to drinking glass to reinforce our connection to the natural world and one another. No matter where you live on this blue marble, it's time to get your brain on water. In closing, I'm here to tell you that the emotional connections created by visits by places like the Back to the Sea Society's Touch Tank Hut are incredibly valuable in helping us to heal our natural world, ourselves, and each other. I hope I've inspired you to learn more about the Blue Mind movement and adopt this mindset into your lives. It's been an eye-opening journey for me and one that I strive to share with as many people as possible. Thank you.
Yay, wonderful. Thank you, Ruby. I'm sure everybody actually does feel a lot more relaxed right now. See lots of heart emojis, clap emojis.
Yes.
One thing I forgot actually in my introducing each presenter, I did want to give a little tidbit about how they're involved with Back to the Sea. So if I can go back to Kaitlin, who started about Kelp. She's one of our longest standing volunteers, has been with us since the very beginning, and is one of our senior volunteers as well. So she's the chair of our communications committee and has just done so much for Back to the Sea. So thank you, Kaitlin. And then Ruby is one of our advisors, also an advisor since the very beginning, someone who's always so keen to share her knowledge that she has. I mean, so much animal husbandry experience that's been really valuable for us. So I'm really grateful to be able to call upon her, even though she's across the country, which is amazing.
Thank you. Yes. That is lovely.
And next we have Sarah McComb-Turbitt, and she's a wildlife artist. She recently did an Instagram takeover. So if you have Instagram, do head over to our page. We saved it in the highlights, and she shared a bunch of cool videos there. You'll see a lot tonight as well, but if you're itching for more, you can go check out our Instagram. Over to you, Sarah.
Okay, great. All right. So my name is Sarah, and yes, I did research on penguins, and more recently this past year, I've shifted careers to be a wildlife painter. Okay, so my master's research was basically on how individual variation in winter foraging behavior, specifically the diving behavior of penguins, relates to their oxygen stores, so how long they can hold their breath underwater, and the different carryover effects that these factors have on if they participate in their breeding seasons. That's a lot to unpack, so if you have questions about any of that, I'm happy to answer them elsewhere. For this presentation, we are going to break it down and start at the basics because I'm not sure what everybody really knows about penguins, but there's arguably 18 different species of penguins that are broken into 6 different genera. And most of them are threatened, endangered to some degree. And those are gentoo penguins, the species that we're going to talk about a little bit more here. So they are one of the species that their whole population is of least concern. But my population that I work with is at the Falkland Islands, which is just off the coast of South America. And they're actually an entirely different population genetically, which makes them a bit unique. So this is a map of the monitored colonies that are breeding each year in the Falkland Islands. And you can notice that they have really large fluctuations in how many individual penguins decide to reproduce each year. So we really started off this process with wanting to understand why their breeding pairs change so drastically. So a few quick facts just to get to know them a bit better. Gentoo penguins can dive over 200 meters down, which is super far. They are the fastest swimming penguin. They are just under 1 meter in height. That's huge. They're very large birds to try and handle. I'm not that strong of a person. So yeah, they're a little intimidating to work with. They are not migratory, and they live over 20 years, and their reproductive potential, what they should be able to do based on research, is 2 chicks per year. So to understand gentoo penguins a little bit better, we're going to go over their annual cycle that happens in a typical year. So we're going to start this off with them having eggs. So this is the breeding season, is October to November for where I work in the Falkland Islands. And incubation lasts about a month. They brood their chicks for about another month, and then the chicks fledge at around 14 weeks. So this entire period, the chicks are reliant on the parents, and it's a very energetically expensive time for them. So then penguins go through a process called a catastrophic molt. Now this is different from other types of molt because it's catastrophic in the fact that they lose all of their feathers at one time. So this happens over the course of 2 to 3 weeks, and penguins can't go into the water during this time period because they lose their thermal protection against the elements. So coming off of this period where they were raising chicks and then had to replace all their feathers, it's really important during the winter months for penguins to increase their body condition so that they're able to participate in breeding again. So this is relevant to my research because not a lot of work takes place in the winter because the environment gets so harsh to monitor them. So what we did instead was we attached tracking devices to the penguins in April and then followed the penguins throughout the entire blue period of months to October when we reclaimed the tags and got information. So how does somebody catch a penguin? So not like that because the sea lion missed, but basically the penguins live in a colony group about 1 kilometer inshore in a cluster, which I've drawn on our map. Then penguins are located in the water, which sea lions have hard enough time catching them, so we have no chance. So next, penguins come up on shore at these rocks, and the rocks are pretty huge. Like nobody wants to run and try and catch an animal on rocks. It's dangerous for everybody. So then we have this nice grass area, and this would be perfect. You know, humans can run pretty fast on grass, but Gentoo penguins can actually outrun humans. So they'd be really, really difficult to catch unless you're like an Olympic athlete or something. And also on the grass, particularly at our colony we were working with, we have Magellanica penguins, which they are endangered. So we want to make sure we disrupt them as little as possible, but they bury in the grass. So extra hazards because you don't want to collapse a burrow when you're walking there. So we avoid it. Anyway, so then we have this beautiful place called the Diddle-Dee Bush, and it's about 1 foot to 2 feet high, and that's about the height of the penguins. So our long legs give us a beautiful advantage to be able to capture the Gentoo penguins. And now you know how we catch penguins. So why did we do this? We wanted to attach tags. So we have an Argo satellite tag and a time depth recorder tag. And there's a stencil around the penguin just to protect the feathers from glue that we use, but it's just tape and glue onto the tags, very little disruption to the feathers. There it goes, ready to collect some data for us. And this is the kind of information we get. So this is the satellite data that we got. And over the course of the first few months, probably about midsummer, all of our satellite tags fell off. And it was a devastating time in my life as a graduate student. But luckily for us, when we went back in October, 22 time depth recorders, the smaller of the two tags, stayed on the penguins. And you can see that you can't even tell where the tag was above it because their feathers are perfect, because science has just come so far away. And yeah, but anyway, so we got the time depth recorders back, and this is what that data looks like. So we have the depth the penguin was at every 1 second for 6 months, which is an amazing data set and a lot to process. And if you want to learn more about that, you can check out my thesis. I'll send you the link. But these are all the list of people I want to acknowledge. And as a fun last minute activity, this is what we saw when we were searching for our penguins coming back to sea. They have numbers on their chests with sheet paint. And you can kind of see 59's about to jump up on a rock. But if you go back in the recording, there's actually 4 different penguins that come ashore in this one clip alone. And we would sit there on the shore with binoculars and search for them, and then get into place at the Diddle-Dee to recapture the same penguins. And that is my presentation.
That was amazing. Thank you, Sarah. I never considered how you would have to catch the penguins, and I'm glad there was some video evidence there. Definitely, if you want to drop the link of your thesis in the chat for anyone that's interested, you could do that. And don't forget, everyone, if you do have a question for any of our presenters, you can ask in the chat, and we'll keep those for the end. Next up, we have Leah Robertson. She's another one of our longest standing volunteers. I actually met Leah at the Petty Harbour Mini Aquarium in Newfoundland, and then she moved back to Nova Scotia and got involved with Back to the Sea. Was the very first staff member I ever hired in 2017, which was a really special moment for her and I. So yes, I'm happy to welcome her, and I'll be the one sharing her slide deck. Okay, and right now, Leah, you don't, wait, let me make sure I see you in my screen. Okay, I see you. If you want to just like maybe give me one of these, and yeah.
Perfect. So today we are going to talk about sponges, and we can jump to the next slide right away. So what are sponges? I think that's probably the most obvious thing that we can talk about here. And it's not the kitchen cleaning tool, but they are actually animals. And so a lot of times scientists will refer to them as porifera to kind of not confuse them with the inanimate cleaning tool. So sponges are typically sessile. It means that they don't move, they don't go anywhere, and they're very porous, which allows for water circulation. And this water circulation is super important. It's how they conduct all of their life processes from breeding to feeding. And next. So why should we care about sponges? I hope, at least in this presentation, to convince you that they're really cool. If you're not going to think they're really cool, I hope you learn something at least. But they do provide a lot of benefits to the environment. For example, they add structural complexity to the areas that they live. This is super important for the deep sea, which parts of it can be fairly barren. They're a refuge for other animals, so tiny microscopic organisms or other animals will often hang by sponges for good reason. They're really important to overall biodiversity of the ocean. And the thing that gets talked about a lot is that they support food webs through their nutrient cycling and their other biogeochemical processes. So what that means is this is usually called the sponge loop, and basically sponges are like really messy eaters, and they're actually pretty inefficient at eating. So they'll take water in, they'll eat some of the nutrients, not all of them, and then they'll expel that particulate matter, which is really good nutrients for other animals. They do the same thing with other things like nitrogen, for example. So they have a really unique talent for keeping nutrients in areas for much longer periods of time than if they weren't there. And next. So I'm going to talk specifically about my research on deep sea demosponges. So here are my sponge babies. This is literally all of them. There were only 4. And you're probably thinking, that's not a very big sample size. And you're right, it's not. But deep sea sponges are like really hard to keep alive, especially at surface level. They're often studied in situ, which means that they're studied via ROV, typically in the water. In this case, these sponges were collected by my laboratory, or by the laboratory I'm a part of. And they were collected as a part of Department of Fishery Oceans sampling, and we got to keep these sponges. And these 4 just like happened to stay alive. I don't know if I have a good reason for that, but we were really excited about it. And because they stayed alive, we knew that we should study them. And we started by being like, well, what do they eat and how much do they eat? And it seems obvious, but these sponges had never been studied in laboratory conditions before. So we really had to start with the building blocks just to see what would happen. And the sponges that we're looking at here, there's 3 different species. The one on the top left is Polymastia. We called this one species 1 because we couldn't identify it further than that. The one to the right, the top right, is Polymastia species 2, very clever. And then the bottom 2 are both Radiella hemispherica. And the one on the right is much bigger than the one on the left. Next. Okay, so basically we fed them phytoplankton, studied how much they ate, and they ate, which was very exciting. We were able to measure their filtration rates, the amount of phytoplankton they were consuming, and the thing that was most exciting for us, or at least most exciting for me, was that they actually grew. So this was in a few months that after doing our studies with the phytoplankton, we could see the sponge grow. The thing that was really cool about this is that deep sea organisms, and these sponges are from 1,000 meters deep, so quite deep in the ocean. If you're looking behind me, it's like way down here. And so they're typically like, it's really slow growing. So it was very cool that we were able to measure growth in the laboratory. It also demonstrated that they were doing well. If they're well enough to grow, it's typically a positive sign. And next. So what did we do next? That was supposed to be the end of my project. We were supposed to just see if they fed, but my supervisor at the time was really excited about our results, and she was like, well, why let's stop there? And besides having a good work-life balance, there was no reason to stop, I suppose. But what we decided to look at was to change some of the environmental parameters and look at basically how that would affect them taking in phytoplankton. So we looked at a number of different things. Some of the things we looked at included changing temperature and acidity, and this was essentially to mimic climate change conditions. And for anybody who's following along in kind of the promos for this event. We also studied what would happen when they were around a predator, because there's lots of studies that sponges, they can smell when a predator is close, and what they do is they stop feeding, and essentially it's like an invisibility cloak, because so many animals use scent to detect each other, especially invertebrates. And in this case, the deep sea sponges did the same thing, kind of like put on their little invisibility cloak and didn't feed. So that was pretty cool. And next slide. So the bad news is when we change those environmental parameters, such as acidifying the water, the sponges did consume a lot less. This shows that they are vulnerable to changes such as climate change. This is not entirely surprising. You know, they're from 1,000 meters deep, and that's a habitat that has very few environmental changes. It's usually very cold, very steady, very dark. So it wasn't totally surprising that when we started manipulating the conditions, but it does give us some evidence of how climate change can negatively affect deep sea sponges in the future. And next. And I didn't want to end on a sad note, so I want to provide some good news. So since the time frame that I did this research, there's been so much more research on deep sea sponges, and some of it is so cool. There's this group that was born called Sponges, and it's an super long acronym, but basically what they're doing is they're working to preserve deep sea sponge grounds in the North Atlantic waters, which if you're listening from Nova Scotia or Newfoundland, that is the waters that we're in. And they have so many good goals as well. It's not just about the preservation, which is incredibly important, but they're also making so much more of their science accessible and open access. So that is my presentation on sponges. I hope you learned a little bit and perhaps think sponges are cool.
I certainly do think they're cool. Thank you, Leah. I love the reference to the invisibility cloak. Okay, next we have Lauren. Lauren Farley is one of our past staff. So she came on board last summer and was able to stay with us throughout the whole fall, which was really exciting. Normally in the fall, I become the only employee, and I really loved having her as a colleague. And she's continued on our communications committee. So I'm really excited to welcome her. And she's going to be talking about sharks.
Can everyone see my screen?
Yes.
Yes, perfect. Okay. So, hi everybody, my name is Lauren. I use she, her pronouns, and I'm going to talk about sharks. I love sharks. They've been my favorite thing for quite a long time. So I'm going to share some facts and some stuff about why they are super cool. So just to start off with some numbers. So I'm currently in Atlantic Canada, and anybody else who's in Atlantic Canada right now. We actually have 21 species of sharks that will visit Atlantic Canadian waters, which is pretty cool. Currently there's over 140 shark species that are listed as endangered or threatened, which is really unfortunate. And humans kill about over 100 million sharks each year, which is also very unfortunate. And to contrast that, last year in 2020, there was only 13 humans killed by sharks. So we can kind of see that there's quite a big discrepancy of what is kind of portrayed in the media about sharks. And currently their biggest threat is fisheries bycatch. So throughout my degree, I've done a lot of research on shark conservation and what we can do to kind of solve these issues. And something that comes up quite a bit is changing the narrative around sharks. So today I'm actually going to talk about 4 of the coolest things that I have found out that sharks do. And typically people will ask me what my favorite shark fact is, and usually I answer with one of these. So to start, shark teeth. So sharks are pretty famous for their teeth, usually not for very good reasons, but they actually do something really cool. So sharks basically will never run out of teeth. So humans, we have our baby teeth, we lose those, and then we have our adult teeth. And if we lose those ones, we're kind of out of luck. But sharks have, they keep growing teeth throughout their whole lives. And as they lose their teeth in the front rows there's always a row behind it ready to fill those teeth in. So they've evolved this way because when sharks eat, typically what they'll do is they'll latch onto a prey item with their teeth, and they'll kind of just thrash around really vigorously. And as you can imagine, some teeth are going to fall out. So it's really good and beneficial for them to always have teeth in the back ready to kind of replace those ones that they lose at the front. So the next one I'm going to talk about, so shark senses. So humans have 5 senses, the taste, touch, smell, all that kind of stuff. Sharks actually have 7, which is really cool. So one of these extra senses that they have is they're able to detect changes in electrical fields in the water column. So if you can look at your screen and you can see all the little dots around the nose and the snout of the shark, those are actually little jelly-filled pores called ampullae of Lorenzini. And then again, they're able to detect changes in electrical fields. So as they're hunting for prey, if their prey, any muscle in like a fish that they're hunting contracts or anything, they're able to feel that in the water. So even if they can't see their prey, they can physically feel their prey and know where they are and where to hunt, which is pretty awesome. And it's also been discovered that sharks might be able to detect Earth's electromagnetic field, and we think that that's how they are able to direct their migration routes, which is pretty awesome. So the next one, this one's kind of gross, but it's really cool, I promise. So this is a phenomenon that sharks do. It's called gastric inversion. So it really means sharks will literally puke their guts out. So if a shark eats something that it can't digest, instead of just throwing up like a normal human would, it would actually just exerts its entire stomach out of its body, which is super weird. And I mean, it works for them. It doesn't hurt them at all. They're able to just swallow their stomach back in and keep going on about their day. And something kind of interesting is some big sharks like this one, I think this is a blue shark here, they'll commonly eat seabirds. So it's common for people who are studying sharks or are around sharks to see this gastric thing and then a little flume of feathers pop out, and that's because the sharks can't actually digest the feathers that are in their stomach. And then the last one that I'm going to talk about is this phenomenon called tonic immobility. And this is super weird. And what happens is for some species of sharks, if they're flipped upside down and their bellies are facing up, they'll just pass out. Or if you see in the picture on the right there, if all of those sensory organs that I was talking about are covered, they'll also, the same thing, will just kind of pass out. And we don't really know why. It's really weird. They enter a coma-like state, and all of their muscles relax, and they don't kind of react to any painful stimuli. So people and researchers will actually use this as an anesthetic when they're tagging sharks. So the picture on the left there is a group in the Bahamas tagging a tiger shark over the boat, which is pretty cool. And they can be in this state for up to 15 minutes, and then you reverse it by literally flipping them back over, and then they'll just kind of, sometimes they'll be a little disoriented, but then they'll just swim away and go about their day again. And we don't really know why they do this or how they evolved to do this. There's some theories that it's for defense or mating, but there's actually no concrete evidence for either of those. So yeah, those are my fun shark facts, and I hope you enjoyed.
Thank you, Lauren. Always good to hear some positive things about sharks. Awesome. Next, we have Sarah Vokey. So Sarah joined the Back to the Sea team in February and was part-time with us and is now moving on to full-time. So it's exciting to have her on board for more hours, and has a lot of interpretation, and she has a geology background. She might say this herself, but so she's not going to talk about species, she's going to talk about underwater volcanoes, which is really exciting.
All right, there we go. Got myself unmuted, got myself on the screen. All is well. So thanks so much for the intro, Magali. So hi, everybody. As Magali said, my name is Sarah. Hi. And I'm here to speak to you today about underwater volcanoes. And I'm going to start my presentation off with everybody's favorite part of any presentation, group participation. Don't worry, it's super, super easy. All you have to do is raise your hand. And I'm really going to be relying on Magali because she is one of the only screens that I can see. So don't let me down there, Magali. All you have to do is raise your hand. So first thing we're going to do, I want everybody to imagine a volcano. Everyone have it in your mind? Mm-hmm. All right. By show of hands, who imagined something like this? Okay. Oh, yeah. I see some hands. I see some hands. Mm-hmm. who here imagines something a little more like this?
Yes.
All right, a couple more people. How about something like this?
No.
Not quite. So you might be a bit confused because I'm showing you a photo of the open ocean. But believe it or not, more than 70% of the world's volcanic eruptions happen right there under the water. As an example, back in 2012, an eruption that eclipsed the sheer power and ferocity and explosiveness of Mount St. Helens, which you're seeing on the screen, occurred. The only thing is, it was only noticed because a woman on a commercial flight noticed a dark spot in the ocean and managed to contact the right people. And that sounds wild, right? I mean, this huge eruption, and we almost missed it. And that's because Havre, the volcano that erupted, is 3,000 feet underwater. And that's kind of the big problem with underwater volcanoes. Researchers have a very hard time studying them because they are so deeply underwater. But we're getting a bit ahead of ourselves here. So let's start, back up a little bit, ask a simple question that you may be wondering right now. Why are volcanoes? Now, the simple answer is that the Earth is always changing and morphing. It's not a static piece of rock. At all times, both ocean floor and the ground that we stand on is constantly being created and destroyed. And at these spaces of creation and destruction is where you find volcanoes. Now, we're about halfway through my presentation, and I think it is time for a little bit more audience participation. Very simple this time. You don't actually have to do anything. You just have to answer questions in your brain. The question is, which mountain chain do you think is the longest in the world? Do you think it is A, the Andes of South America? Do you think it is B, the Rockies of North America? Or do you think it is C, the Himalayas of Asia? Think about your answer. Now, the answer is, of course, none of them. That was a trick question because I was deceiving you. In truth, the longest mountain range on Earth is a string of underwater mountains, volcanoes, and trenches known as the Mid-Ocean Ridge, pictured here in red. You can see it spans the entire globe, stretching like stitches on a baseball, and it comes in at a whopping 65,000 kilometers long. And this is where crust is created by these thousands of kilometers of underwater volcanoes. And that's quite interesting. But when something is created, it must then be destroyed. And that brings us to the geological feature with perhaps the coolest, the most metal name in all of geologic history. I'm talking, of course, about the Pacific Ring of Fire. It's less of a ring, it's more of a horseshoe, but it stretches from New Zealand up through Japan, along the Bering Strait, down the side of North America, and finishes up at the tip of South America. And this is an entire area where crust is being destroyed, and thus you have volcanoes. In fact, you have over 400 active volcanoes. In fact, it has a volcano that we've already seen. That's right, we brought Havre back. This is the volcano that erupted back in 2012, and it is actually located off the coast of New Zealand, so right within that ring of fire. Now, as a geologist, I think these are cool just because they're volcanoes, but for any of the more biologically inclined people out there, underwater volcanoes are also quite important because underwater volcanoes are associated with hydrothermic vents. This beauty on screen right now is a black smoker, and it hosts hundreds of different species, such as tube with red and Dumbo in the stylings of The Little Mermaid. Now, I'm totally out of time, so I'll leave you with this. Underwater volcanoes may be mysterious, they may be hard to research, and they may even be dangerous, but they're super cool and they're incredibly important to our world. Thank you.
Awesome stuff, Sarah. That was so interesting. So there's some nice puns happening in the chat here. Okay, so we had 6 amazing presentations from people who do a lot of science and talk about science. And now our final presenter is Sonya Lee. She's with Ocean School and she's a supporter of Back to the Sea. She's been following our work for quite some time, I believe. And I wanted to invite her because she does a lot of work on science communication. So kind of bundle everything in a nice package. She'll talk about how do we communicate this science. And I'm the one with that presentation. So I will share it. Oh.
It's really hard to follow that awesome presentation, by the way.
You will do awesome, I know it.
You didn't see me, but I was laughing out loud. So hello everybody, my name is Sonya Lee. My pronouns are she, her, and I am a science communicator. So we heard from so many cool scientists and people who are trying to get people to connect with the oceans, and we've heard lots of great science communicators tonight, but what I do is I do the same thing, but just all the time. And so how do we get people excited about ocean science or make connections with the ocean? And that's where people like me come in. So we can go to the next slide, Magali. So this is my job. You don't see me, I'm not in front of the camera, I'm behind the camera. So as a science communicator, what I do is I bridge the science and the scientists and people who are unfamiliar with those science topics. And I say that because, you know, there are a lot of us on this call probably who are also scientists, but science is a very, very big, broad field. So like I, as an ocean science background, might also need a science communicator to tell me about, you know, like NASA rockets, for example. So everyone in a lot of different fields can be a science communicator, as we have seen tonight. So as a science communicator, what I do is I try to figure out how to best reach the audience that I'm trying to connect with, and then figure out an interesting way to talk about the science. And everyone tonight did such an amazing job. And with my job as a science producer with Ocean School, Ocean School is an online education media project of the National Film Board and Dalhousie University. And we create free online educational material for grade 6 to 9 students. And we help teachers teach everyday school curriculum, but through an oceans lens. So for me, my audience are grade 6 to 9 students, but also teachers who have to teach just everyday science and how to do it in a cool, unique, visual way. So in the picture, we are in Celtic Nation on the central coast of British Columbia, and we are sitting in a wildflower meadow and learning about how ocean nutrients get into the terrestrial ecosystem. Next slide, please, Magali. And we've heard a little bit about sharks today, and right here we are filming shark tagging off the coast of Costa Rica on a remote volcanic ring of Cocos Islands. And so what I do is with Ocean School and as a producer is I combine documentary filmmaking and education and science, and we use these tools to tailor a message to meet the level of my audience, which is grade 6 to 9, making the vocabulary, making how we present the information make sense to that group, and we also make sure it's easy for the teachers to access based on the tools that we create. Next slide, please. This is my crew filming in Celtic Nation again. What we do is we actually film a lot of scientists. We like to put the people behind the scientists, tell their stories and learn how to do the science, but also show how do scientists or people in general find problems? How do we ask questions to solve those problems, and kind of role model that behavior of question asking and finding answers? So this is Alejandro Frid of the Central Coast Indigenous Research Alliance, and he is catching some Pacific herring to do some surveys in Heiltsuk Nation. Next slide, please, Magali. And we, in Ocean School, we use not just visual filmmaking, but we use a lot of different kinds of tools that are appropriate for our audience. So that can be an educational activity, that can be 360 immersive experiences, that can be a website, a blog, whatever fits our target audience, whatever is the best tool to tell our story, we use. So here, what we're doing is we're documenting a scientist in Raja Ampat, Indonesia, finding new species. So we're talking about biodiversity and how there's so much life still out there that people and scientists discover new species all the time. And so we document the process of how do scientists even know it's a new species. So he is holding out a species, like a new potential species, on a little pin. He's taking pictures in its habitat, and then we go through the process of preserving that specimen, doing DNA testing, and all the way to figuring out whether or not it's a new species. Next, Magali. Yeah, so you can check out our stuff at Ocean School, and everything's online for free at oceanschool.ca, and our Instagram is Ocean School Now. So just like the last note about science communication is, like, I keep saying audience, and because audience is so important for science communication. So like I said, my audience is grades 6 to 9, but it can, you know, like you can have young kids at, you know, Back to the Sea Aquarium, for example. You have young kids, but you also have adults who accompany those young kids, and you also have grandparents or, you know, babysitters. And so these are the general public, but within a general public, you also have these niches and a lot of different audiences you are trying to connect with. So that's something that I like to always talk about when I'm talking about how to do science communication better. There's no such thing as general public. Okay, there's always somebody and another way to connect with, and that's a challenge to everybody on here who wants to do science communicating, to figure out what that connection can be and tailor your messaging to specifically to that audience and age group. So that's just kind of what I do in science communication.
Okay, and on that topic of audiences, there is one question here in the chat. If there's plans for Ocean School to create content for grades 10 to 12, so teaching life sciences and biology 11 through a marine lens.
Yeah, so a lot of our stuff actually can be tailored older or even younger. We say our target audience is grade 6 to 9, but we've had high school students or high school teachers all the way up to grade 12 use our content because we have a lot of support material that teachers can run with as well. So definitely check it out.
Great. Thanks so much, Sonya. So that brings us to the end of our presenters. We ran over time, but like everybody stuck around, which means everybody was super interesting. I believe that Sam has managed to fix his audio issues. I will invite him to hop on and say a few words. Are you still there, Sam? Okay, maybe not. I will reshare my screen actually, just to give a little conclusion. Okay. So, I had a great time tonight. I'm so happy you were all able to make it out. As a reminder, this was all part of our Making Waves initiative. There's a lot of great comments. Okay, and Sam is in the chat saying thank you to all the presenters. So another huge thank you to Sam and his team at Deloitte for their support. So if anybody missed it at the beginning, if we're successful in getting 55 new monthly donors this month, Deloitte will donate $5,555. And so will you be one of our last 10 people that we're looking to recruit tonight? If you're interested, you can check out our website, backtothesea.org. If you do /Making Waves, it'll take you directly to the link of Making Waves. And we also have one last thing happening as part of this whole initiative, and that's our final Instagram contest. It's going to be taking place on Instagram, of course, on Friday for a signed copy of a book by Acorn Photography. I think it's called Coastal Nova Scotia. Did I get that right, Sarah? Yes. And if you don't have Instagram, you can still participate by sending out an email to us at info@backtothesea.com. So keep a lookout for that. And so I will let everybody slowly trickle away, but if ever you do have any questions, I don't believe I missed any questions in the chat, but feel free to just unmute yourself and I'll just ask the presenters to stick around until everybody's left and you can ask the presenters directly. We can make this interactive. So thank you so much for attending and have a wonderful night. Seeing people leave. Lots of nice comments in the chats for our presenters. Right. How's everybody feeling that presented tonight?
I feel great.
Good.
Yeah, I hadn't looked at some of those slides since I defended my thesis over a year ago. So I was like copying and pasting slides into the presentation. I was like, whoa, this takes me back.
You beast. That's awesome.
Yeah, sorry if it was a little quick, but.
Oh no, it was great. Oh, Haley Leonard is here. She's one of our volunteers. Hi, Haley.
It's always so humbling to go to any science presentation, any marine presentation, because even after like a degree and a lifetime of loving it, you're like, I don't know anything about the ocean. And it's such a cool feeling. It's such an exciting feeling.
It's true.
I agree. Also, Sonya, it was so cool hearing about your work.
Oh, thank you. It was so cool hearing about volcanoes. Sorry, I like have a bit of a migraine, so I was like hoping I was cohesive, but I can't see like this part of my eye.
Oh no, sorry to hear that.
Well, even without part of your vision, that was awesome.
Yes.
That's great. Yeah.
We could not tell that. Oh,
Yeah,
if you
great
want to
job,
log off, Sonya,
everybody.
and give your eyes a rest, please don't hesitate.
Yeah.
Everyone did such a great job from a science communication perspective.
Yeah.
Awesome.
Okay,
I
well,
have
don't
to
think we-
actually get going here too, you guys. I've still got a little bit of work to do because I'm on the West Coast and it's
Right.
just trying to finish up my workday. But thank you so much. It was such a great, bunch of information, and
Yes.
how awesome that everybody's presentations totally worked. Great job, everybody. Good job on the practicing. Thanks so much for having me. I love it. I love the East Coast, and I love being part of this. So thanks, everyone.
Thanks for joining, Ruby. That's such a
Bye.
good point. It's so rare that there's no huge technical glitches,
Yeah.
other than Sam, I guess, not being able
Yeah.
to.
My mom says, a job well done by all.
Oh, yes.
Thank you, Sarah's mom. Okay, I think it's safe for everyone to log off then. And
Thanks again for organizing.
thanks so much, Sarah. I really appreciate it. It was nice to see you. Nice to see you, Lauren, as well.
Yeah, good job, everyone. That was really good.
That was awesome. I was so surprised how fast everything flew by because I was just like, oh my God, tell me more about everything.
Yeah,
Yeah,
I didn't
so-
even realize we were over the time. I was like, oh, really?
Yeah. Also, I was so just so happy with how Kaitlin did her presentation because we were chatting and she was like, is it okay if I take it a little goofy? And I was like, yeah. Oh, that was so fun.
I mean, that's what I was expecting of Kaitlin, and I knew that's the type of presentation she'd give. So, yeah, Goofy's always welcome.
Yep. Good stuff. All right. Have a good night, guys.
Have a good
Thanks,
night.
you too.
See you later.
Bye.
Bye. I wonder if I can, any questions from you, staff, or are you all good? We'll see you tomorrow then.
Hmm.
Yeah. And,
Well done, Sarah. You're good.
pardon?
Well done, Sarah. Your presentation was really good.
Yeah,
It
Thank
really
you.
was, Sarah. I really enjoyed it.
Sarah,
Bye.
you seem so natural. Like there's literally no nerves at all. I'm
It,
like jealous.
I think so. Here's what happens: is about 2 days before, 2 to 5 days before a presentation, I get hit by this just like tidal wave of anxiety, and I feel it in my whole body. And then
Mhm.
about 3 hours before a presentation, I'm like, I'm on top of the world. I got this. I'm a superstar. And then right before the presentation, I'm like, what if I'm not a superstar?
So
It's a
just
journey.
before we keep going, Sarah, are you able to kick, because you're the host now, are you able to kick off Haley? I'm assuming she's away from her computer.
Oh, sure.
If you go on the participants, there's a little drop down, and I think you'll be able to.
Oh, there you go.
Yes, Sarah, I purposely put you in that spot in the lineup because I was like, we'll see how it goes. Like, I know pretty much how everybody presents, but by then we'll be nearing the end. And I was like, I know I need someone that won't be fumbling, it's got her stuff, natural interpreter, that's what you need near the end. So that's why I put you there. So didn't want to put that pressure on you beforehand. But now that you succeeded, I can tell you.
You know what? That's how you have to do it. After something happens, you got to be like, so here were my machinations. No, that was awesome. Everyone just had such cool, fun, interesting things to say.
Mm-hmm.
Yeah, and I'm really happy with the turnout. I mean, 42 participants through the end.
Yeah.
Yeah, some people did leave and come back, but including all the staff, everyone, I have 51.
Nice.
Wow.
Yeah. Cool.
That's not bad at all.
All
And I
right.
think some people might be 2 people too.
I saw a couple screens that were like Steph and someone.
Yeah, Steph and Kyle, I think those are Leah's friends. They always come up as names when we talk about Back to the Sea stuff. When she's like, I'll recruit friends, it's always them.
And then you have my family watching from different rooms.
Are they?
My mom was like, oh, here, I forwarded it to your brother and sister, and your father's teaching a class tonight. And I was like, you guys are all in the same house. Did something change that I didn't know about?
They're social
So
distancing.
funny. Yeah. They're just too used to.
They're taking it really seriously. Oh boy.
Yeah. Okay, cool. Tomorrow at some point, I'll be dropping off surprises to each of you to have for a virtual party, so you can expect me to pop by. I'll text you when you'll just all be working, so I'll text you when I'm there.
Oh,
Surprise, come out and meet me.
Maggie, I
Yeah.
just want to tell you that before then, it's totally okay if you can't, but my sister's on night shift right now, so in the morning she was going to pick me up, and then I was going to work from home from her house while she sleeps, and she lives in Prospect Bay. So I think it's a little
that's
far.
Yes. Okay. So that might not work.
I'm sorry. This just like, we just decided this today because she's like, oh, you know, I don't have to come back and get you. You can just come with me after my night shift at 7 a.m. I was like, okay, I'll be up anyways for work.
That's okay. Well, now I already said it out loud, so I have to follow through with everyone else. But you'll be the birthday girl with no treat.
How far is Prospect Bay from this end of town? I have a vehicle. I could, if Magali drops yours off with me, then I can do the second leg of the drive.
I think from my house, it's about 25-minute drive. It's right near Terrence Bay.
Oh, okay. Yeah, no, I could totally do that. Like if we want to do that.
It'll be like an hour back and forth. You want to do that for real?
I feel so bad. I ruined the plan.
Oh no.
Oh, good thing I said it though. Imagine I would have just shown up at your house.
Yeah, and
like, I'm not here.
I felt so bad.
Yeah, no, I'm totally good with that. I'm due for just like a drive anyways. I don't know if you guys ever find this, but sometimes, you know, you just get in the car, you drive, you by yourself, you play your music.
The drive's actually nice too. I'm not even just saying that. Like some of it's actually along the water, but
if you're willing, Sarah,
it's
not like
anyone wants to meet me at like 7:30 when my sister gets home, that's really early.
No, thank you.
I understand. I don't want to leave it either.
Okay, sounds good. So I will see you all tomorrow.
Excellent.
Either in person or on Slack.
Okay.
Perfect. I'll see you guys tomorrow.
All right.
Bye. Have a good night, everyone.
Thanks, you too.
Bye.
Bye.